Yeah. Good day. How are we all doing? Sorry. I'm pretending red. Okay, so today we're going to solve Leetcode 108, convert sorted array to binary search tree. So the question says, given an integer of array where the elements are sorted in ascending order, convert it to a height balance binary tree. So first of all, you need to take note of some keyword, I guess. You need to take note of binary search tree, and then we need to take note of height balance. So first of all, a tree is a data structure that looks something like this. It's kind of like a tree kind of like a tree if you look at it, right? Like a Christmas tree, I guess, like a family tree. That's it. That's what a tree is basically. Is a data structure. But now we're not just talking about tree. We're talking about binary search tree (BST). Okay, so first of all, let me explain what binary search tree is. (BST). So binary search tree is an implementation. It's a tree basically, but it's a special kind of tree that does that is arranged in a way that it allows for log n of inputs and log n of of popping of removal. Log n of removal, log n of input and log n of searching, I guess. So a binary search tree is a tree. If you are familiar with binary search, it's similar to binary search in the sense that if you're looking for something, you you check the middle, then you go either left or right based on it. But I'll give you an example of binary search. This is an example of binary search. Let's say I have 5. Every binary search tree, everything to the left of the binary search tree is always lower than that particular node. So starting from this particular node 5, everything at the left of 5 will be lower than 5. So this could be 2, this could be 10. Everything at the right will be higher than 5. This could be 1, this could be 3, this could be 7, this could be 20. So basically, a binary search tree, when you take a node, any node that you take, anything to the left of that node will be lower, anything to the right of that node will be lower. For example, if you take the node 2, everything left to the node 2 will be lower than 2, 1. Everything right to the node 2 will be higher than 2, 3. If I want to put, for example, now let's say I want to put 8 inside this binary tree. The 8, we know that 8 is greater than 5, right? So it can't go to the left, it's going to go to the right. If it goes to the right, 8 is less than 10, right? So it can't go to the right, it has to go to the left. If it goes to the left, 8 is greater than 7, so it can't go to the left, it has to go to the right. That means 8's position would be here, basically. 8 position is going to be here. Yeah. So if you look at it, although the inserting is not a straightforward insertion, it's not just take the last element I put in. It's not a constant time insertion, it's a log n insertion. Although the insertion is log n, if you want to find something, it's also log n. So if I want to find let's say I want to find 10, I don't need to be checking one by one. I don't need to check, is this 10, is this 10, is this 10, is that. I just start from the root. Since 10 is greater than 5, I know that 10 cannot be at the left of 5. It has to be at the right of 5. So I go to the right, I check 10, and I get 10. Boom. Do you get it's I don't know if it's very simple, but it's not very hard. So yeah, so that's what a binary search tree is. So another thing we should take note of is the height balanced. So the meaning of height balance is basically the left side, the height of the left should balance the height of the right. So if you look at the left, the height is just 1, 2, 3. I'm coming, I was about to sneeze. If you look at the right, the height is 1, 2, 3. So it's balanced. The height here is balanced with the height here. Yeah, so that is what they mean by height balance. So now back to the question. The question says that if you are given a sorted array in ascending order, turn it to a height balanced binary search tree. So for example, take this question: minus 10, minus 3, 0, 5, and 9. How do you turn it to a balanced tree? If you turn it to a balanced tree, you have 10, 5, 9, minus 10. You have it like this, basically. So in this question, the trick is actually finding your root, the best root. For example, I cannot use minus 10 as the root. So let me just go back to the board. So the question is minus 10, minus 3, minus 10, minus 3, 0, 5, 9. Sorry about it. So I can't take minus 10 as my root, because if I take minus 10 as my root, right, minus 3 will have to go to the left, right? Since minus 3 is less than 10, minus 3 will have to go here. 0 will have to go here. Since 0 is... Oh, sorry, minus 3 is greater than 10. Sorry. So I'll be having minus 10, minus 3. 0 will have to go to the left of minus 3. 5 will have to go to the right, sorry, of 10. 9 will have to go to the right of 9. This is not balanced. To the right of this is 0. To the left of this is 1, 2, 3, 4, 5. This is not balanced at all. Same thing too, if I pick minus 3 as my root, I'll be having something like this, minus 10. I'll be having something like this. So in order for me to make it balanced, I need to pick the right root. And since it's assorted, is not assorted, sorry. Since it's ascending, the best place to take your root will be the middle. Since you know everything to the right of where I pick my root would be greater and everything to the left would be less. So if I pick my root at 0, I know that everything to the right of 0 would be greater than, would be at this portion. Everything to the right of 0 will be at this portion, and everything to the left of 0 will be at this portion. So with this, I could get a balanced height. But then let's say I'm having a very long array. If I'm having something like 0, 1, 2, 3, 4, 5, 6, 7, 10, 11. If I pick the middle of this will be maybe something like this, right? I'll be having 6. Then I know everything like this would be in this portion, and everything like this would be in this portion. But if you look at it, you can actually see that we can do something like a recursion where we can pick this as a new array, right? That we want to, a new sorted array is also sorted, another new sorted array that we want to do something similar. So that means at this portion we also want to pick the middle, which is 3. Then we know everything to the right of 3 would be in this part, and everything to the left of 3 would be in this part. Same thing too, we want to pick the middle, which should be, I think, 9. Everything to the left of 9 would be in this part, everything to the right of 9 would be in this part. So basically I want to do something like a recursion where we take the middle of the array, we create a node, and then we now attach to the left of it a new function that would do basically the same thing that we just did, and attach to the right of it a new function that would do basically the same thing we just did, but you'll be passing a different array. So you'll be passing the left part of the array to this function, passing the right part of the array to this function. I hope that's explanatory. So basically what we'll be doing is we would have a function, right? Our function will first of all take the whole, we can decide to make the function take the whole array, right? Then inside the function we are going to divide the array into 2, right? Then we'll call the function again, but this time we'll be passing this portion of the function to the array and this portion of the function to the array. When it enters the function again, this is also going to divide it into another smaller part of the array, right? And then this is going to divide it into another. I'm guessing you can say how this is basically divide and conquer, right? We keep dividing it until we get to the base case where there is no array, and then we return. So it's going to keep dividing We need to keep dividing. Then it's going to return and just bubble up to the. As well, breaking it will be basically attaching, right? So yeah, that's just it. Let's code it, and I'll explain more as we're coding. So yeah, so this is a question. So we start by creating a function that would vary recurse. So I'm going to name it recurse. So this function is going to take in the array, right? And what we want to do is we want to split the array. So first of all, we want to find the middle of the array, right? So we want to get the middle man of the array. So in this array, we want to get the middle, the value of the middle, and create a node from it. So first of all, we do middle would be equals to basically the length of the array, right? /2. That's going to be the middle index, right? But the array, the value of the array itself will be equals to the array. The value of the array itself will be equals to the array and the middle index. So then what we want to do is we want to create a node at that point. So I'm going to call it node, and then we want to attach to the node a left part. Now the left part is going to be what will be attached to the left part will be everything at the left of the array is going to go to the left, and everything at the right, since it's sorted, is going to be at the right of the array. So in that sense, we want to I guess before that, let us divide the array first. So say this is the left part of the array. The left part of the array would be the array from the beginning of the array to where the array to the middle, from the beginning of the array to the middle of the array, and the right part of the array would be from the middle plus 1 to the end. So now what we do is we're going to call our recurse function again, and this time we're going to pass in the left part of the array, right? And then we're going to do something similar, but this time we're going to pass in the right part of the array, and then we're going to attach it to the right part of the node. And once we're done, we want to return our node. I'm forgetting something. We're forgetting our base case. So our base case would be if the array is empty. So I can just check the length of the array, and that length of the list, whatever, you get it. If the length of the list is 0, if the length of the list is 0, we just want to return. We don't really want to do anything in that situation. So basically, if we get to this part of the array, right? If we get to the part of the array that is nothing, we want to return, meaning that we've gotten to the edge, right? We want to return, and that should be it. So at the end of the day, we're just going to call our function recurse, right? Hey, I'm not getting the spelling. Recurse, and then we're going to pass in the array, and then that will give us our roots, and we'll return our roots. So let's just go through the function again. So we'll be passing in the number, that's the whole array. Inside the whole array, it's going to first check if the length of the array is 0. If it is 0, it's going to return. If it's not 0, it's going to get the middle value and create a node from that middle value. Then it's going to split the array into two, the left part and the right part. So the new node would attach to the left part or the array in the left, and the node will attach the right at the array in the right, which is going to recurse again, basically doing the same thing, and it's going to keep creating the node, attaching until it gets to a place where there's no node, and just return. Yeah, so I guess we can try this, right? And fingers crossed. Okay, yeah, we don't really need to cross our finger. It works. Cool, it works. Yeah. I just want to say another way to solve this is we can, instead of passing in the array itself, we can just pass in the index of the array. So we know the index, because we're not actually using the array, we're using the value of the middle. We can pass in the index. If we pass in the index, we can know the middle of the index, then we can know the value at the middle. It's just, so instead of passing in large chunk of array, we can just pass in the index of the array. But yeah, that's how to solve it. And yeah, thank you. Bye bye.